Okay. So this guy just cancel, you get 1, right? And the same term in the numerator, this sine alpha over cosine alpha, you get the tangent alpha. Sine beta over cotangent beta, you got the tangent beta. Right. Now let's look at the denominator. And this cosine beta and cosine beta cancel. Sine alpha over cosine alpha, you got the tangent alpha. And this cosine alpha and cosine alpha cancel. Sine beta over the cosine beta, you got the tangent beta. And this is exactly the right side. So in this way, we verify this identity. Now let's look at the section 4. Let's look at the page 543. And let's look at the problem 48. We know sine of the 2 alpha. And we also know the position of this 2 alpha. Then we need to find sine alpha, cosine alpha, tangent, cosecant, secant, and cotangent. Okay, we need to find those 6 trigonometric function values at alpha. So this is the page 543. Problem 48. We know sine of the 2 alpha is equal to negative 8 over 17. And we also know 2 alpha is greater than 180 degrees and less than the 270 degrees. So that means we have this 2 alpha in the quadrant 3, right? In the quadrant 3, cosine of the 2 alpha is negative. So first, let's get the cosine of 2 alpha by the fundamental identity. Cosine of 2 alpha is equal to negative square root of the 1 minus sine square of 2 alpha. Okay. Now you plug in negative 8 over 17 for sine of 2 alpha, and then you simplify, get negative 15 over 17. So after I find the cosine of 2 alpha, then I can use the half angle identity to find the sine alpha and cosine alpha, right? So this is why I first need to find the cosine of 2 alpha. So before we can find the sine alpha, let's determine the position of the alpha. From this inequality, okay, we divide each part by 2. Then we have the 90 degrees less than alpha, and then less than the 270 degrees over 2. That is the 135 degrees. So this just implies alpha is in the quadrant 2. Right? Now, by using the half angle identity for the sine alpha, we know sine alpha is equal to, since alpha is in the quadrant 2, so sine alpha is positive. Then by the half angle identity, the sine alpha is equal to the positive square root of 1 minus cosine of 2 alpha over 2, right? And before we have the plus minus sign before this radical sign. But right now we know the position of alpha, and we determine the sign of the sine alpha, which is positive. So we just take the positive square root of 1 minus the cosine of 2 alpha over 2. This is half angle identity for sine. Then we plug in this negative 15 over 17 for this cosine of 2 alpha. You have the 1 minus negative 15 over 17 divided by 2. Then you simplify. You can get 4 times root of 17 over 17. Okay, you can use a calculator to simplify, and if necessary, you need to rationalize the denominator. Now, we can also get the cosine alpha. Cosine alpha, since alpha is in the quadrant 2, so cosine alpha is negative. And either you can use the half angle identity or you can use the fundamental identity. So right now, I use a half angle identity. So negative square root of 1 plus cosine of 2 alpha over 2. And this is negative square root of 1 minus 15 over 17 and divided by 2. Then you have the negative square root of 17 over 17. Cosine of 2 alpha is equal to negative 15 over 17. So this is 1 plus the cosine of 2 alpha. You got 1 minus 15 over 17. Okay. So now after you find the sine alpha and cosine alpha, then it's easy to find the other several function values at the alpha. Let's get the tangent alpha. Tangent alpha is equal to sine alpha over cosine alpha. And this is equal to 4 times root of 17 over 17 and divided by negative root of 17 over 17. So this root of 17 over 17 cancel. Okay. From the numerator and denominator, then you get the negative 4. Then cotangent alpha, which is equal to the reciprocal of the tangent alpha. So you got the 1 over 4. And the second alpha is equal to 1 over cosine alpha. So cosine alpha is equal to negative root of 17 over 17. Then you can multiply both the numerator and denominator by 17, and the 17 and the 17 cancel. So you have the negative 17 over the 17. Then you can rationalize. And finally, you have the negative 17 times root of 17 over 17. So you got negative root of 17. Now let's look at the cosecant, which is equal to 1 over sine alpha. So this guy is equal to 1 over sine alpha is equal to 4 times root of 17 over 17. So you have the 4 times root of 17 over 17. And then next, in the case of the second alpha, you can simplify this, then you get root of 17 over 4. Done. Right, since the cotangent is equal to 1 over the tangent alpha, so I forgot the negative sign here. So it should be the negative 1 over 4. Thanks. Any other question? Let's look at the 52. And this time, we know the sine of a half angle. And then we need to find those 6 trigonometric functions at alpha. So let's go to the whiteboard.